Good morning class. Today we will discuss how we prepare potassium dichromate and potassium permanganate. Student, now let us discuss one by one. First we are taking potassium dichromate having formula K2Cr2O7. It is one of the most important chemical compound. It is prepared in 3 steps. In step 1, first we have a chromator FeCr2O4 which are treating with sodium carbonate in excess of air to convert it into sodium chromate. Sodium chromate is yellow color solution which on acidification converted into sodium dichromate having formula Na2Cr2O7 which on treating with KCl give potassium dichromate. Potassium dichromate has orange color crystals. It is one of the most important oxidizing agent and in various chemical reaction it is used as oxidant. The structure of chromate and dichromate ion are here. In chromate ions are generally yellow in color, while dichromate ion, that is Cr2O7 2 negative charge, are orange in color. Both chromate and dichromate ion are interconvertible. If pH of solution below 7, the color of solution is orange, that is dichromate ion exists. If the pH is greater than 7, chromate ion exists and the color of solution become yellow. It should be noted sodium dichromate is more soluble than potassium dichromate due to high degree of hydration enthalpy of sodium ions. Now let us discuss potassium permanganate KMnO4. It is one of the most important chemical used as oxidizing agent and widely used in treatment of boils and also used as germicide and sold in market under the name Lal Dawa. It is prepared by the reaction of manganese dioxide with KOH to form green color potassium magnate solution, potassium magnate, which on acidification give potassium permanganate. The structure of magnate and permanganate ions are mentioned here. Here the magnate ion MnO4 2 negative charge is green in color, while the permanganate ion MnO4 single negative charge are purple in color. I repeat it again. Two most important chemical are potassium dichromate K2Cr2O7 and potassium permanganate KMnO4. Potassium dichromate is prepared by 3 steps. In first step, chromate ore is treated with sodium carbonate in excess of air to convert it into sodium chromate, which is yellow color solution, which on acidification gives sodium dichromate. Sodium dichromate on treating with KCl gives potassium dichromate, which is orange color solid. Chromate and dichromate ion both are interconvertible. Chromate ion formula CrO4 2 negative charge, it is yellow in color. Dichromate ion formula Cr2O7 2 negative charge, it is orange in color. Sodium dichromate are more soluble than potassium dichromate due to high degree of hydration enthalpy. Potassium dichromate are widely used as oxidizing agent in various chemical reaction. Now the second compound is potassium permanganate, as I described earlier, KMnO4. It is prepared by the reaction of manganese dioxide with KOH to give potassium magnate, which on treatment with acid gave potassium permanganate. The main difference between manganate and permanganate ions in only a single negative charge. In manganate ion 2 negative charge will be there, but in permanganate ion only single negative charge will be there. The color of manganate ion is green while the permanganate ion is purple. Potassium permanganate is widely used in the treatment of boils and also sold in market under the name Lal Dawa. It is added in walls to disinfectant water. Now, one mark question may be asked from this topic, which is based on balancing the equation, complete the reaction. It are of type like that, complete the reaction, in which we have to balance as well as complete the reaction. One mark question may be asked, in which it is given Cr2O7 2 negative charge plus I negative gives. Now, how we solve this type of equation? It should be noted chromium is stable in +3 oxidation state. So here we write Cr3 positive and I negative will be there, then it will goes to I2. Now here we notice that chromium in plus 6 oxidation state goes to plus 3 oxidation state, that is reduction take place. Chromium reduction, while the iodine minus 1 oxidation state goes to plus 0 oxidation state because iodine is a free and is in free state. So oxidation take place. Now split the equation into two half reaction, that is the oxidation half reaction and reduction half reaction. Now balance the atom. Minus 1 goes minus 1 to 0, deficiency of 1 electron. When we multiply it with 2, deficiency of 2 electron will be there, which may be balanced by adding 2 electron to right hand side. Now we have Cr2O7, 2 negative charge, in which chromium is in plus 6 oxidation state by oxidation number method. Now here the chromium 2 atoms are there, multiplied with 2 to make it equal. Now deficiency of 6 electron will be there, adding 6 electron here. Now our next step is to balance oxygen atom. Here no oxygen atom, nothing add to it, but here 7 oxygen atom on left hand side, so we are adding 7 water molecule on right hand side. The next aim is to balance hydrogen atom. No hydrogen will be there, nothing add to it, but here total number of hydrogen are 14 on right hand side, so we adding 14 H positive ion on left hand side. Now balance the equation because acidic medium is given. 2 electron is there, 6 electron is there. Multiply this equation by 3 and then adding equation this, we get, here we have 6I negative plus 14H positive plus Cr2O7, 2 negative charge gives 3I2 plus 2Cr3 positive plus 7H2O. So by this way we can balance the equation. The correct balance equation of Cr2O7 double negative plus I negative gives Cr3 positive plus I2 is this one. Now let us try to solve some more equations. Suppose we have in the second part, suppose we have MnO4 single negative plus Fa2 positive gives Mn is stable in plus 2 oxidation state, iron is stable in plus 3 oxidation state. After seeing this equation, we notice that Fe2 positive is oxidized to Fe3 positive, while MnO4 in which manganese has plus 7 oxidation state reduces to Mn. Now first aim is to split the equation into two half reaction and then balance the equation by adding electron to electron deficient side. Now here MnO4 single negative plus 5 electron gives Mn2 positive. Now balance the oxygen atom. Here no oxygen is there, nothing add to it, but here the 4 oxygen is there, adding 4 water molecule this side. Now balance hydrogen atom, nothing added to it because no hydrogen is there, but in this equation 8 hydrogen on right hand side, so we are adding 8 hydrogen ion on left hand side. Now multiply it with suitable integer. Here the 1 electron, here the 5 electron. Multiply this equation by 5 and then adding in this equation we get 5 Fe2 positive plus 8H positive plus MnO4 single negative gives 5 Fe3 positive plus Mn2 positive plus 4H2O. So it is the correct way to balance the equation. So with the help of this method, we can balance and complete the chemical reactions.